Okay, hello, good evening. Um, I'm Kenny Grip, product manager at MySQL, working on high availability and InnoDB. And we have Miguel Araujo, right? Okay. Who's the admin API tech lead. And I have a few slides today, and he's going to be like showing the demo. And yeah, I'll try to keep it short on the slides and show a little bit what MySQL InnoDB cluster is. Yeah, and that's it. So, topic of today, InnoDB cluster. First of all, yep, some slides. Okay, good. So, who does not know what MySQL InnoDB cluster is? Okay, one. Okay, only one person. Perfect. Who is already using MySQL InnoDB cluster? Has tried it? Any of that? Okay, a few. Okay, good, good. No, okay, great. So, who's using MySQL 8.0? Fred is. Who is not using MySQL 8.0? Okay. Okay. Perfect. So, short amount slides. What is MySQL InnoDB cluster? So for you, sir, only person apparently, I have some slides. So MySQL InnoDB cluster is a single product consisting of a few components in order to bring easy, high availability, scalability features in an easy to use solution. And that's it. That's very much it. And this is how it looks like. We have MySQL group replication. Have you heard about that already? MySQL group replication? No? No worries. Good. So group replication, which is where the data resides. We have MySQL router, which is the connectivity from the application towards the database. So into kind of like a proxy. And then we have MySQL shell, which is a new shell in MySQL that is there to set up and install and configure the router and the group replication and make it easy to use. So that's basically it. So 3 components. So what is the goal? We want to make sure that we with this one product basically that we have various different components in, like we see here, and they all developed by different teams. They're installed on different servers, and by combining this, we're actually developing all of these components together. And when we're introducing a new feature in any of these components, we have to ensure that all the other components support this new feature or new behavior as well. So it is fully integrated. We do testing. We have a QA team that does this full stack testing for all of these, for the full MySQL InnoDB cluster. So it's easy to use, MySQL shell. That's what Miguel is going to demonstrate today. Yeah, we also have a new protocol in MySQL 5.7, which is the X protocol, which gives you an SQL, but also a NoSQL interface to MySQL. And yeah. And InnoDB cluster kind of uses that in certain cases. So group replication. So I'll show you every one of these 3 components very briefly on what they do and what they are specifically. So group replication is a highly available distributed MySQL database. So it provides you a lot of things built into this cluster. So it does fault tolerance, it's automatic failover. You can configure it to be active master, so you can write to all the members at the same time. Membership is automatic, so you can add members, remove members. They will provision themselves. When there's a network partition, it will take care of making sure that only one remains the primary and that split brains are prevented. There's integrated conflict detection and resolution for this, of course, and it's all built to make sure that there's no data loss, no split brain, no data loss. Very important. So here's a little bit more information. So it's basically an implementation of replicated database state machine. So all writes in the cluster are ordered. Another important thing that I didn't mention yet is that all members in the cluster, or all members, have the full data set. So this is not like where you can get write scalability. So all members will contain all the data. So if you want more write scalability, you need to use MySQL NDB cluster, which is another product that can help you with that. There's a new feature in 8.0.17, which is the clone plugin, which allows you to provision a member that has no data with all the data without having to replay all the relay binary logs since the beginning of the database, which are usually not there, of course. So we have like a physical snapshot that is taken online, copied to the new server in order to make sure that when we add a member, it gets added fast and easily. So this is fully integrated in group replication as well. So you can use this clone plugin also with asynchronous replication if you're using 8.0. So this was made generally available, so InnoDB cluster in 5.7, but there's lots and lots of enhancements that we made in MySQL 8.0 that make this more easy to use, add a lot of features. For example, per session or global read and write consistency that you can configure on all members, so you can ensure that there's no stale reads if you read from any of the members. It is just built using the MySQL framework as well. So if you remember binary logs, relay logs, global transaction IDs, it's built on top of that. So it's no different in that case. And it supports all platforms that MySQL supports as well, of course. So no data loss, split BAME prevention, I mentioned it already. Automatic failover. So if you, by default, it runs in single primary mode, which means that there's one writer and multiple reader members. If that writer member gets network isolated, it will automatically move to one of the other members as needed. Read scale out, so you can add more members in order to increase your read capacity. It is So if you use the default consistency level, which is eventual, there is no guarantee that if you write something on one member that all the other members have executed already. However, there is a guarantee that if a transaction is committed on one member, that in case of that server failing, that one server fails, that the other members have, or some of the other members have received it. So it's implemented using a Paxos protocol. We call it XCOM. So the majority of the members must have received the transaction before the transaction can be returned back to the application saying that, okay, the transaction is committed. So it is possible that there's kind of like replication lag, which you're familiar with asynchronous replication. However, you can control how much replication lag you want. So there's flow control. There's a lot of settings there where you can configure, hey, I don't want, so if a member falls behind and is not applying transactions, the cluster can actually slow down the writes to make sure that all members can sync up and that the replication lag is not just growing and growing and growing. So active-active is supported. There are some limitations, of course, and you can write to many members at the same time. Still guaranteed consistency. All writes are ordered in the group, and the write performance is actually quite decent. So it uses optimistic locking, and only when you commit the transaction, it is sent to the other nodes. So it's not like a two-phase commit that needs to happen, which requires 2 round trips, but there's only one network transfer to all the members, of course, so it's sent multiple times. And yeah, that's it. Shell, next item, is basically a shell where it helps the DBA, the operator, developer to log in, do a lot of commands. There's JavaScript and Python and SQL interface. And today we're going to show JavaScript. And yeah, that's it. I'll just go a bit quicker and so we can show more demo, of course, much important. So next up is router. Router is the kind of access, does the routing between the application and the database. So the router is a stateless design, so it has almost no configuration. So router would say, okay, I want the router to connect to the group replication. So you could bootstrap it. It bootstraps itself. And then the configuration is actually, a lot of the configuration is stored in the group replication metadata schema. And Shell can then make some changes and router adapts to that. So there's like no user management necessary on the MySQL router. All of this is done with the regular grants that you configured in the group application, and so on. If you add members to the group, the router will automatically pick it up. It notes that the topology has changed, that the primary has changed. It gets notifications of that through the X protocol, like, okay, the view changed, I have a new primary. Routers adapt and they connect to the other nodes. So currently, there's a port for reads and a port for writes. So it's basically a TCP-based load balancer. So it load balances the reads, it can load balance the writes if you have multiple primary mode enabled, and that's it. And look, I see a lot of demo, and that's basically what I wanted to show today and wanted to go into the demo. Miguel. So what we have Tmux. Is this okay, readable at the end? Michel? Yeah? Okay, good. So we have the shell running here, just running. It's not connected to any database right now. It's just the shell has started. On the right bottom, by the way, we have sysbench running to one member. So basic to a database. So there's no cluster yet at this moment. And we have a data set. It's about 3.5 gigabytes. So we try to keep it small. So what Miguel is doing now is he's connecting to a server, the server that sysbench is using right now. So he says connect root at localhost, and he's in JavaScript mode now by default. So I'm just following what he's typing, right? So it's surprising what he's going to do. So \SQL, he goes into SQL mode for that statement, runs a query. You can go to Python mode, you can go to SQL mode. Now he's in SQL mode, showing the schemas. So you can see we have a database called app, now in Python mode. And you can do all of the operations that we'll show today in JavaScript. You can do in Python mode as well. Yeah, let's create a cluster. Perfect. Do you want to talk?
I will type, right? So first thing you have to do before creating a cluster is to prepare an instance to be ready for it. And that means group replication requires some specific settings in place. And for that, we have this command, which is called configure instance, that will prepare your instance and set all the configurations there. And for that, we use set persist. You want to talk a little bit about that?
Okay, sure. Set persist. So one of the features that we added to MySQL 8.0 is the ability to change the configuration, the my.cnf basically, of a server just through the SQL interface. So you can say set persist, InnoDB buffer pool size. Well, you cannot do that. You can actually do it online. You can change it online. But when the database restarts in 5.7, it would be the old value again. With set persist, it would actually write it to the data directory in a MySQL auto.cnf file, which means that when the server starts, it reads the file, it knows all the changes that were done. And what Shell does, Shell leverages that. And Shell knows, okay, this is an 8.0 instance. I do not need to tell the user, please update your my.cnf. It can actually do that for you, and it's going to suggest you that. So it's quite interactive. So here you can see GTID is not enabled, so this is default configuration. There's a server ID as the default. Binlog checksum is something that needs to be 0. So it says here, okay, we can do this dynamically. Do you want to do it? Yes or no? Okay, we do it dynamically. The next question is, do you want to restart the server? So again, this is Shell. Shell only uses SQL Connect. The classic protocol using port 3306 or the X protocol to connect, but it can also restart the server because that's some other functionality we added to 8.0. So what he's doing now is, yes, restart. You can see that sysbench, the application is not doing anything. Okay, the server is restarted now, and it came back. Okay, so now you're checking the instance configuration to make sure, is this instance good to be used for group replication for InnoDB cluster? And it says, yep, it is. So we can create a cluster now. So Miguel is creating a cluster object, and then he says dba.createCluster with the cluster name called WePay. It creates a single member cluster, of course. We only have one member at this moment. And it's configuring everything. It's adding some metadata schemas and so on. The next thing we want to do, and we have actually a couple of other instances running. We have port 3306, which is this member. We have 3307 and 3308 running. So we want to add these. There's no replication running. There's no data on those hosts. And that's what we're going to do to add the second member. But first, you're going to show the status.
So the status, let me, can you hold this? I want to know. Of course. Okay. So the status is, it's the entry point for monitoring of your cluster, and it will give you information about the name, the basic settings in place, which is the primary instance. We only have one, so it's here, 3306, and it gives you the status of your cluster. Right now, it doesn't have any tolerance because we only have one member, and we need 3 to have tolerance for at least one failure. And it will give you the information about the topology of the cluster. Right now, we only have one. It's here. It's only primary by default, like Kenny was saying. InnoDB cluster runs in single primary mode. The instance is online. Here's the topology mode information. So this is the output of cluster status.
So can you do Control B colon resize with no Control B go up, yeah, Control B colon, let's just Control B and then colon this, yeah, he's using a Portuguese layout, and then resize dash and then a window or no space, resize window dash, and then minus D, capital D. Capital D, 15 or something, or resize pane, sorry. So we want to make this a little bit larger so you can see more. Pane, P-A, just tap, you can complete autocomplete. Just press tab. Yeah, minus capital D, 15. Yeah, or you can do minus U to go up a little bit. Anyway, so you can see a bit more now. The next thing that you're going to do is add a member? Okay. Oh, configure the member. So we have, okay, you want to talk?
Yeah.
Sure.
So just to show you the command to check if the instance is ready for InnoDB cluster, because the one before was we configured first and then we show it that was ready. So I want to show how it looks like for one that is not ready for InnoDB cluster. So here's the output of each variable that needs to be changed in order to get the instance ready for cluster usage. And now I will just run the configure instance, localhost 3307, same story of before, perform, restart. So also something in MySQL 8, we can do remote restarts using SQL with a new SQL command, which is called restart. We make use of it, we leverage it on the shell. So next step, adding the instance to the cluster. The command is quite simple. The admin API is really straightforward. Every command name basically says what's going to do. So add instance, we add the instance to the cluster. And now, you want to talk about?
Yeah, sure, if you want. So this host has nothing, no data, nothing. And it says here, okay, the target has not been pre-provisioned. Why? Because the GTID set is empty. So there's nothing in there, no schema, nothing. So currently the shell doesn't know what it has. It's possible that GTID was disabled and some data was added, but we don't know. So what we are going to, what is suggested here is to do a clone. So clone is that new feature in 8.0.17, which was released last month, or 2 months ago, actually, where you can fully provision a host that has no data by taking a physical snapshot of the first member, copying that over to this new member that is joining, and then restarting it, bringing it back up with the actual data. So it's doing this through MySQL connections. It's doing this online. It's using things like called backup locks, which is the same as what MySQL Enterprise Backup does. It also does it online using those backup locks. So what Miguel is doing now is, okay, we need to do clone. We cannot do incremental because, yeah, we don't know what the GTID set is here. So clone is happening. So what happens is the node is added, and group replication actually by itself will determine, or will actually invoke the clone operation. So this is not something Shell is doing. Shell is just observing right now. So you can see Shell is doing the file copy. So 3307 is being cloned from 3306. The 3 gigabytes was copied. 3307 is shutting down, so it has to restart the database, do some recovery to bring back the data at the state it was on the donor. The server is being restarted right now, waiting for that. So it finished. It did it at 350 megabytes per second. It's two local machines. And what happens now when that server comes back, group replication starts and it knows, okay, so there are still some transactions running here. There's still some replaying to do, some recovery mode, we call in group replication, for the member to have all the latest data. So during that restart and during this page and redo copy stages. So it does it through asynchronous replication configuration, which it automatically does for you. And yeah, after a while, the instance was added to the cluster. So we can do cluster.status, and you can see two members now, 3306, 3307. This one is in read only, the other one is read write. So in this case, we have two members, which is good, but we see here the cluster is not tolerant to any failures. So what we have is two members, and in order to do the split brain prevention or network partition handling, it looks at the quorum. And if there's a network partition between those two, well, both of them see 50%, they see themselves, which means that they don't have quorum, they need more than 50%. So you need an uneven amount of members. So with 3 members, you can lose 1 member. With 5 members, you can lose 2 members to still have the system up and running. So what you're gonna do now is add the 3rd instance. Okay, we're adding the 3rd instance. The same way, so it will just take a minute. Did you configure it already? No, but it asks you, oh, you're configuring first, good. Same thing, root at localhost, clone. Yes, question, go ahead. Yes. Anything like that, then that will basically block writes from the master. Pseudo GTID, you mean the set? Well, I just had to notice that something I was doing up, but any DDL changes will be blocked from the master. So the backup locks allow reads and writes to continue, but if you do a DDL, that DDL cannot happen. So DDLs are kind of blocked. Well, it's not that all DDLs are blocked. It's the DDL on a table that is being copied cannot be changing. That I think that so not all operations can be done online, but we'll check that. Yeah. So if you do add indexes all the time, everywhere, remove, create, do a lot of alter tables, then that will not necessarily be fully online. Yes. Correct. So it's the same thing with MySQL Enterprise Backup. When you take a backup online, the same limitations happen. Yeah. It's the same. Yeah. Yeah. The same with extra backup. Yeah. Okay, we have a 3-member cluster. Okay, cluster is online and can tolerate up to 1 failure. So we have 3 members, 2 read-only, 1 read-write. Do you want to do any other exercises, Miguel?
Bootstrap the router.
Bootstrap the router. Okay. So need to show. Yeah, you can talk.
So I'm going to bootstrap the router. Like Kenny was saying, you can automatically bootstrap your router. It will configure itself automatically for the target cluster. I'm going to do it now, and then we will change the application that is running on Sysbench to point to the router, so it does its job of routing the queries to the right place.
Perfect. So it's a MySQL router. It was installed in a different location, so he's looking for that now. So the command is MySQL router, bootstrapped. You need a super user to connect to the database. He's now doing it in a custom directory, but so this is optional. So when it bootstrapped, it created a MySQL account for the cluster management, for the router to connect and check the status. It generated the configuration, and so MySQL router gave you 4 ports. So when you start MySQL router, you'll have 64467, 7, and then with a 0 added to it. So for classic read write, classic read only, X protocol read only, and X protocol read write. And this is kind of how the config looks like. Yeah. So the config that is getting generated is here, but you can change some things. You can change some routing strategies if you want, the ports it needs to listen to. But what is important here is the destinations. It's using the InnoDB cluster metadata cache or the group replication, the WePay cluster, and here it's asking for primary roles. Here it's asking for a secondary role. So it will connect to all the, so when the router starts in the cache, it knows, okay, these are all the members that I had last when I started. It will try to connect and then ask for all the members again, and it will update its own cache as members are added and removed. Okay? Starting the router. So router is started. And then this little terminal. Okay. Okay, so now what Miguel is doing now is through the shell, he's connecting through the router port 6446 and doing select hostname port to show like, okay, we're connected through the router and we're now arriving at port 3306, which in this case is the primary member right now. So what you can do now is add the application to Sysbench here to connect through that router. Here, the read-only one. So 6447, and then when you do a query on 6447, which is the read-only classic port by default, is you get 3308 in this case. So now we're changing it to connect to port 6446, and that should work. So everything is connected through the router, but everything still goes through the primary member, which is which is 3306 right now. Now maybe the last exercise is we take a node cleanly out with stop group replication and shut down a member. So yeah, we're taking the primary, we're doing stop group underscore replication and then shut down. To just mimic, this is a clean shutdown, basically. And what you can see is that the new primary was elected. And do cluster status. And router connections were killed. And the application, Sysbench in that case, had to reopen a connection. And yeah, it arrived at 3307 right now. That's it. Shall we? Yeah. Any questions? If not, we're around here. I guess Fred wants to talk. No? Yes. How is it different? It has a lot of similarities. Yeah, it has a lot of similarities, but it's quite different. This is fully relying on replication, binary logs, GTID. So that is kind of different. So this also is based on a Paxos, using Paxos protocol to send to gain consensus with all the members. Galera does something else, but it's pretty much similar in the end result of that. This is built by the MySQL team. Yes, one product, one thing. Well, I think the important is we built this. Actually, Louis and his team. Where is Louis? There he is. Who is the director for replication? He also develops a group application. His team. So it's all built by the same team in MySQL. Exactly. Yeah. And you can switch to asynchronous application, go to group application. It is GTID set that counts. So you can just stop asynchronous application, or adding to asynchronous application, you can start a cluster, you can add members. So you don't have to, like with Galera, you would throw away the data. It needs to do a full state transfer first before a node can be added. Here, it's just, if it can use replication, it will. If not, it will use clone. So this is a lot easier. Yeah. so just a lot more integrated, which is the goal that we have with MySQL InnoDB cluster. Same monitoring infrastructure, yes, yeah. So if you look at the replication performance schema tables, if you're in group replication or asynchronous replication, it's the same. So you see the same type of information. Yeah. This is multi-platform. Galera is not. Yes. Yeah.
So what happens if there is a replication line in this case?
Well, if so, let's say you have single primary mode. We write a lot, but one of the members has a lot of read workload and is slower in applying the transaction that happened in the group. So it's going to have a queue of transactions that it's basically behind. So what will happen is the other members that are having write transactions will know, they can see how far behind or what the status is of every member, and they will start to throttle the writes on their that they are processing themselves to make sure that that other member catches up. This is configurable. There's like 10 variables that you can say, when does it need to start? When is that lag too much? How much do I need to slow down and throttle my write workload in order to, like, what is acceptable to you? So you have a lot of configuration that you can do in this.
So the automatic payload will still have
there is no issue. It's just a member that is slow to apply transaction. It's still working. It's still receiving all the messages. It's just when a member is not able to respond anymore after 5 seconds, basically a member will be suspected to be gone, and then certain things will happen depending on configuration. But a member falling behind is not necessarily an issue for the group membership. Nothing else? Fred? Europe?
no question.
No? Oh, Mirko, yes.
Support provided by Robert. One is for writes to primary, if you are in a single primary mode, and the other is to distribute according to any policy, round robin policy, to three instances.
Mm-hmm.
Two by default.
Well, 2 in this case, yeah.
Just the secondary.
By default.
You can see it in the config. It said destinations role the secondary. So it was filtering on, give me only the secondary nodes, and the routing strategy, first available or round robin. There's a round robin with fallback or first available. So you can see this in the configuration here.
I want to distribute the three, all the instances, I just change it manually and restart the robin.
Yes.
Round robin.
Well, yeah, you stay in this round robin. So you want to connect to all 3, right? Yeah. So you don't say that you want to roll secondary only. Yeah, that's it. Yeah. Okay. Thank you very much.